Welcome, ladies and gentlemen, for another episode of Study Like a Nation. Today I have two really special guests, Zeynap on the left and Samra on the right, and to help me out to actually explain to you some basic work on projectile motion. Now today's question is particularly interesting because it's about a projectile starting from the same height and end up at the same, how can I say it to you, alright?
Stop. Okay. So this is the question. So a projectile has a range of 750 meters and reaches a maximum height of 58.8 meters above its launch point. So part A is, what is its time of flight? Well, for this we can easily use S equals to U plus half A. So when we look at this projectile, it's actually going flat, and this is the projectile. So the information that we actually have is it has a range of 750 meters. And the maximum height, which will be right in the center, is 58.8 meters. So now that we know what the projectile actually looks like, we can actually use this formula to find the time of the flight. So we know that the actual x equals to 58.8. And that equals to, because uy will be, because the vertical velocity is actually 0. And a has to be negative 9.8 because it's going against gravity. And we are trying to figure out the time. And because this is 0, we can actually cancel that off. So it becomes negative 58.8. And if we were to solve this, then we'll get t squared equals 12, and t equals to root 12, which equals to roughly around 3.46. However, this is a common mistake among little girls. Basically, that's actually the time it takes to reach the maximum point. So 3.46 seconds is this time here. However, because this is symmetrical, we have to times it by 2 to figure out the entire time, which becomes 6.92 seconds. So that's part A. So in order to answer the second question, what is its launch velocity, we have to look at this point right here because that is where it's actually being launched from. And we're trying to figure out the velocity, which is this line here. So if we were to draw this triangle over here, that's theta, so this is the angle at the horizontal, and this is our initial x component and initial y component, and that's our v, so velocity. So we're trying to figure out this v here. And in order to figure that out, we need to first know what these are, because we know that range equals to x into t. And if we are to look at this, then we also know that t from our previous question is 6.92, and we also know our range is 750. So if we know these, then we can write down 750 equals to ux into 6.92. And from this, ux equals to 108.38 meters per second. So this is our ux, and therefore we can write this then as 108.38 meters per second. So now all that's left is we have to figure out uy, and basically we can use S equals to uy into t plus half a t squared. unknown because we already know that S equals to 58.8. However, that is at the maximum point. So because we're looking at the launching point, which is right over here, our S is actually 0. So if we put that in, 0 equals to ui into t, which we figured out before was 6.92, plus half into, and this again is negative 9.8 into t again, 6.92 squared. So if we use this, we'll figure out that ui equals to 33.9 meters per second. And we can put that back in here. And because now we have two sides of a right angled triangle, because this is right angled because we're using x and y component and they're perpendicular to each other. So then we can figure out v, where v squared equals to ux squared plus ui squared. So v squared equals to 108.38 squared x 33.9 squared, and v, if we were to just root all that, will actually equal to 113.56 meters per second. However, a common mistake is people normally forget to incorporate the angle when we're figuring out v, because velocity is a vector quantity, so you need the direction as well. So we have the actual measurement here, but we also need the angle. And that's actually quite simple using tan theta, because we are given both opposite and adjacent. So if we were to use that, then we know that tan theta equals to opposite over adjacent. That then equals to 33.9 over 108.38. So then theta would equal to the inverse of tan. And that equals to 17.4 degrees. And so our actual answer for the launch velocity will become 113.56 meters per second at 17.4 degrees to horizon. Alright, so we have a batter and he hits a ball at 30 meters per second. So basically this is like a parabola again. And then we have a triangle and that. So it hits at 45 degrees at 30 meters per second. And it wants us to calculate how far from the bat a fielder should stand to catch the ball at the same height as it was hit, so pretty much they're at the same level. So this is just the range. So to find the range, we use the formula ux times t. And we're not giving ux or t, so we actually have to find both of them. So to find ux, that's ux, oh, sorry, and that's ui. And then we just use normal trig to do that. So cos 45 would give you ux over 30, because that's our hypotenuse. And then we do ux equals 30 sine cos 45 and then when you calculate that, that gives 21.21 meters per second. So we found ux, and now we have to find t. And the way to find t, pretty much we could use, we could find the t at where v equals 0. That's the stationary point. So if we use the formula, which one is it? Yeah, so if we just use v equals at, so our v equals 0 at the top. Our u is our vertical, like ui, and we don't have that yet, so we have to find ui as well. Plus negative 9.8 times t, which we're looking for. So to find ui, we do trig again. So you could just do ui equals 30 sine 45. And because sine and cos give the same value for 45 degrees, we just have the same as ux. So 21.21 meters per second. So we just sub in the values. And from here we find t equals 2.16 seconds. But again, a common mistake. This t is only the time up until it reaches the maximum point. So because this is a parabola, it's symmetrical. So we just times it by 2 to find the total time, and that gives 4.43 seconds. So that doesn't answer our question. We still have to find it. So yeah, maths error there. It was 4.33. So when we put that back there, you should get 91.8 meters. And that's your range from here to here. So yeah. So B is asking for flight time. So calculate the time of flight if the fielder catches it. So we already calculated that previously. So we times it by 2, the time we found up until the maximum. So that gives 4.33 seconds. Yes, not seconds. And C is saying calculate how high the ball would rise after being hit. So to calculate how high, it's pretty much asking for the maximum height, because that's where you hit the maximum. So your max height is also like your displacement. So we use the formula S equals to UT, UT plus half AT squared. So we're solving for S. So we have S equals to, our U was our UY, and that was 21.21 times by T equals to, so T over here was 2.16, so we sub in that, plus minus 9.8 because of gravity, and then T, we already have T, yeah, so 2.16 squared. And then when you calculate that, it should give you 22.95 meters. And that is your maximum height.